We're going to start the event now. So again, I'm Flo. I'm the Corporate Innovation Manager for the US branch of TrueSpace region. So I will be your host today for our tech meeting dedicated to hydrogen. So this session will be recorded, so please let me know if anyone would be against it. Great, so let me share the agenda for today. So after a short introduction of what we do, I'll provide some key figures about the hydrogen industry. Then we will move to the fireside chat with our experts today, so Pete Rocha and Frank Le Baron, to discuss the industry and tomorrow's big trends of innovation. And so we will finish this event with a selection of innovative companies presenting their solutions and products. So we will answer questions at the end of the fireside chat. If you have any to our experts, so feel free to use the question feature of Livestorm to ask a question. Great, so let's jump into it. So with a short presentation of TrueSpace region and what we do. So for some of you who don't know us, TrueSpace region is a catalyst for business and innovation. So we partner with Fortune 500 corporations in order to support international companies willing to expand and set up business in the Paris region. So thanks to our presence and vibrant tech ecosystem located in San Francisco, New York, Beijing, Shanghai, and of course, Paris, we are able to get in touch with over 4,000 international companies every year. So this unique relationship between large corporations on one hand and with innovative, fast-growing companies on the other hand, led us to create the Global Open Innovation Network about 5 years ago. So through this global program, we organize about 20 events a year to foster business and technology partnerships between large corporations and startups. So since the pandemic moved our events online, it allowed us to connect and get in touch with more people, more companies. So it has been a pretty interesting experience. So in terms of topics and technologies, we cover a narrow of them. As you can see here, it goes from AI to mobility, retail, health, and you name it. So today we are going to talk about hydrogen. So before we go to the overview of the hydrogen industry, I wanted to present the person in charge of the hydrogen department at TrueSpace region, Sevinch Shimo. She couldn't be here today with us, unfortunately. So I'm going to give you some information about the industry and the different initiatives in the Paris region. So the Paris region is a key territory for the sector of hydrogen in relation to the energy transition. So the region has pledged to make renewable energies account for 40% of Paris energy consumption by 2030 and for 100% by 2050. So it's a big objective. Hydrogen is key for reaching this target, as the region aims at developing the value chain of green hydrogen based on local renewable energies. So in terms of application, we especially count on hydrogen for mobility and for small and medium-sized industries. So we can see an increasing number of projects between industrial groups, institutions, and intensive transport players. Of course, not to forget the 2024 Olympic and Paralympic Games will be the first carbon neutral games and showcase the region's hydrogen solutions for athletes and spectators' transportation and electricity supply. So a rich hydrogen ecosystem already exists in the Paris region. So engineering schools, hydrogen R&D centers, and all those things are generating opportunities for new entrants. And it's the concentration of corporate headquarters of Fortune 500 companies which many of which have a direct link to hydrogen. So in case you have an expansion project toward Europe and you would like to know more about opportunities in the Paris region, please do not hesitate to contact Sevinch. Great. So we're going to move on with the brief overview of the hydrogen industry. As you may know, it's composed of very different actors from various industries. So it's Linde, Air Liquide, Messer, Hydrogenics, Total Energy, Engie, etc., etc. But we can't really define like an industry that is really like just hydrogen. And we can find a lot of actors in sectors like transportation or construction, where we also have actors in the hydrogen sector. And we'll actually have some example during the startup presentations. So here are the key figures I wanted to share today. I wanted to stop on three main figures really quickly to set up the base of our discussion with the panel. So the first one, in 2022, the global hydrogen generation market size was valued around $160 billion. So based on a PwC report. Something important as well is that by 2050, hydrogen could be accounted for 20% of the world's final demand energy element. So it shows that hydrogen is one of the major energy sources of the future. And so in 2022, the market demand for hydrogen was around 99 million metric tons and is expected to reach 204 million metric tons in 2030. So we can see here the main predictions, and they will raise over and over in the coming years based on other industries transitioning their solutions or product or initiatives into hydrogen. So like I said, those trends and industries where hydrogen is a prominent source of energy today, as we can see here, are the manufacturing industry, transportation, planes, cars, trains. We have building construction and power generation. So to finish this brief overview of the hydrogen industry, I wanted to share this non-exhaustive market map with you. So we designed it based on different players we haven't identified on the market. So it's missing a few actors, of course, but it gives us a good understanding on what is happening these days. So I don't want to get into too much details. So if you're interested or have a question, feel free to reach out to me, and I will be glad to tell you how I built it. Great. So without further ado, I'm going to invite our two experts today for the Fireside chat. So Frank and Pete, if you can join me on stage. Hi, Frank. How you doing?
Hi, Florian. Hi, everybody. I'm very fine. What about you? Good?
Yeah, I'm doing great. Thank you for being here today. So we're just going to wait for Pete. I believe he had like some issues. Okay, so I think he's here. I'm just going to invite him. Great. So maybe we're going to first start with an introduction and maybe a presentation of yourself and like the company that you're representing, or like the different initiatives at Engie, Frank, while Pete is going to join in a second.
Okay, great. Thanks, Florian. So good morning, good afternoon, everybody. I'm Franck Le Baron. I'm working at Engie at group level for coordination around hydrogen. So I'm really dedicated to hydrogen. You know, Engie, we've got 2 feet at Engie. We are really a gas company. We are a renewable energy company. So hydrogen is in the middle. Hydrogen is in the middle because when you think about hydrogen today, I mean, I should have started by that. I don't know how familiar your audience is with hydrogen, but why are we talking a lot about hydrogen? What is new? I mean, hydrogen has been used in industry for decades. There is...
Yes, go ahead. Go
There
ahead,
is
Frank.
noise.
Yeah.
Okay, that's better now. In fact, hydrogen has been used in the industry for decades. What is new is that now we know how to produce renewable hydrogen, and in the coming years, renewable hydrogen will be at the same price or equivalent price as non-renewable hydrogen. So the bet is that hydrogen will really play a role, and even if at the beginning hydrogen will not be completely renewable, maybe ultimately the idea is to decarbonize the industry, the planet, the mobility. So what I wanted to mean is that at NG, with this gas expertise, experience, with the renewable energy experience, hydrogen is obvious. We need to play a role. And we want to play a role all along the value chain, from production as an investor, developer, and operator of production of renewable hydrogen, but also transportation. When I say transportation, this is by pipelines. We have a huge history and experience in gas pipelines at NG, building, operating. So we want to do the same for hydrogen dedicated pipelines. Underground storage as well. It's important to store hydrogen. And of course, distribute hydrogen for the mobility, for industry, and so on. So all along the value chain. And I will stop here because I'm sure you've got, Florian, many questions for us. So this is my just quick introduction about what NG wants to do. All over the world, by the way. I mean, not I should say not all over the world, in selected geographies. But we'll come back to it, I suppose.
Thank you so much, Frank, for joining us. Hi, Pete. Can you hear me well?
Yes, I can, Florian. Thank you.
All right, great. Thank you so much for being here, Pete. Yeah, so same thing. Sorry about the little issues just at the beginning. Do you wanna present yourself maybe to tell about like your company and like the different initiatives in a minute to give some context to the audience?
Sure, I'll give a little brief overview and then we dive into the questions. So Pete Rocha, I'm co-founder and head of commercial development at Hydrogen Works. So Hydrogen Works is a startup that's focused on next generation solid oxide cell technologies. So what we have done is license a couple of technologies from leading research universities, and we look to scale those up and integrate those in a full fashion to solid oxide cells, both for hydrogen production and energy storage. Just to, I thought maybe diverge a little bit from what Frank said, or just to differentiate what we're doing. We're not focused on the entire value chain as a company. However, we need to understand, all the important mechanisms of getting the product to the end customer. So our technology, again, primarily is on the production side. However, we do see a great need for the distribution infrastructure, for storage infrastructure, and certainly the last mile, let's say, to the end customer. All those are very important to kickstarting the hydrogen economy. And I think, going back to your first slide, and something that Frank noted as well, hydrogen is already being produced in massive quantities. What we would like to see is of that 105 million metric ton increase would be in renewable hydrogen primarily, right? And I think that the way technology is trending, and certainly the carbon incentives globally, are underscoring the need to do that. And so over the next decade, we'll see hopefully a lot of green hydrogen coming to market.
Yeah, definitely, I agree with that. Great. So thank you for being with us. We're going to start the discussion. And my first question is a really general question. And you talked about it obviously in your both your introductions, but I think it's important to start by this because hydrogen is a very trendy topic at the moment. Everyone's kind of talking about hydrogen because it seems to be very important for the different energy sources and for the climate. So my first question is why and how hydrogen is different from any other like energy sources, and why is everyone talking about that one in particular? Frank, maybe you wanna start with that?
Yes, maybe I started to answer part of the question at the beginning. I mean, what is new is that now we know how to produce renewable hydrogen, and this is key because renewable hydrogen is important for decarbonization, of course. And why we are talking so much about hydrogen, I mean, now, but in the past 3 years, this is because of that, because there is a bet that there could be parity in terms of price compared to non-renewable hydrogen. And this is the reason why so many countries have now prepared their roadmap for development of hydrogen, because they believe that there is something to play. If they want to play a role in the decarbonization of the planet, and maybe also in development of works and so on, employment, they have to act now, to prepare themselves now. And we can see that in addition to these roadmaps for developing hydrogen, many countries have also decided to launch investment program, even some subsidies, because today, in order to quick start this, sometimes project needs subsidies. It's the beginning. Of course, a project has to be on a complete life self-sustainable, I would say, or self-autonomous. But at the beginning, there need to be a quick push to start this project. And if there is this momentum around hydrogen, this is because everybody is understanding that hydrogen is not the solution. Hydrogen is part of the solution. There will be still gas, there will be electricity, but hydrogen can be can play a significant role for not only the decarbonization of industry, when renewable hydrogen will replace or displace gray hydrogen, but also for new usages, like maybe we'll come back to it later, about e-fuels, in the mobility sector. When you put hydrogen in a fuel cell, it is very virtuous for the mobility, and I will finish by that to give the possibility for Pete to answer. But in addition to the fact that hydrogen can help decarbonization, hydrogen can also contribute to the quality of life, because a fuel cell vehicle, a bus, a train, or whatever, will only produce water vapor. So no carbon, as we said, but no emission, no smoke, no vibration, no problem, I would say. So it's really also not only for the decarbonization, but also for the quality of life, especially for the cities. And I'm speaking too much, so please, Pete, your turn.
No, that was very helpful to set me up, Frank. I appreciate your overview and insights. I would just kind of add also, when you look at where hydrogen can help. So in the US in particular, there's a pretty strong lobby for the electric vehicles, batteries, and you hear the kind of the phrase electrify everything. Well, without, I'm not casting aspersions on those, there are definitely places where electrification comes in, but you can't electrify everything. How do you electrify a plane? How do you electrify steel manufacturing? You can't, right? And so carbon, I think one of the huge advantages for hydrogen is in the so-called hard to decarbonize sectors. So if you take away transportation, let's say you can electrify that, and then you have power generation, you still have 50% of global emissions that are in industry, in agriculture, primarily from fertilizer use, and in home heating, residential and commercial heating applications are probably the next three big sectors. Hydrogen can address all those, right? So the ability, it's not only what hydrogen can do as an energy carrier and to provide green alternatives, but also specifically where you can apply it. And again, the hard to carbonize sectors are going to be very important, because quickly as we try to reach the goals of the Paris Agreement, electrification is a wonderful tool to make some headway quickly, but we want to look beyond that. When you get out 10, 15 years, what's still going to be remaining in the large carbon emitting areas, hydrogen is a key, I think, to addressing some of the sectors that I mentioned.
Sorry, Florian, if I may add something that I forgot. We can see that to produce renewable hydrogen, you need renewable energy. This is water electrolysis, I would say. But the reverse is true as well, because renewable energies could need hydrogen. What I mean is that renewable energies are intermittent. And the difficulty is to store the electricity. You can do it by battery, but this is limited in time and in quantity. Hydrogen can be also a way to store the surplus of the renewable energy that is intermittent or variable, and then give it back. Of course, let's say the efficiency is not so good, but if you store something that is free and you store it, and then you can give it back in a few weeks or months, this is also an interest of hydrogen that you can think of. Sorry for this.
No,
that's great.
Point.
Yeah.
I'm going to use that to make another point, because that is something at Hydrogen Works we're very much interested in, is the energy storage application. And to Frank's point, some of the studies that we've read and that are out there in the public domain indicate that battery storage probably can get you to 65% renewable penetration. Beyond that, as was mentioned, the intermittency becomes a real problem. Long duration storage is needed over 24 hours, over the course of weeks, interseasonal. And some of the studies that have been shown show that with hydrogen long duration energy storage, you can get to 95 or greater % of clean grid. So yes, we need renewable electricity to produce the hydrogen, but hydrogen ultimately enables higher penetration of renewable electricity and decarbonization of the grid. So that's an excellent point, Frank.
Yeah, and talk about this. I had this question, and it could be kind of there's never a stupid question, but I'm saying my question would be like, with all those initiatives lately around hydrogen, is it the end of fossil fuel? Pete?
So I think the simple answer is it's going to be a long time before we're off hydrocarbons. The infrastructure in the way everything is built, obviously, the modern economy is built on hydrocarbons. So we have, a long legacy of things. I mean, they're still using horsepower in certain parts of the world. Now so the transition away from animal power in some parts of the world isn't even complete. So to say fossil fuels are going to be complete, I think is a little bit much. What I do think we can get to, though, is a much higher percentage and using a mix. Really, some of where we are now is an energy transition that I think is really the key term that I keep coming back to these days. And going from an economy where 90% of the energy consumed is hydrocarbon based to an economy that's less than 50 is doable, I think, in the next 10 to 15 years if we apply these technologies. But there's going to be a long tail, and I think the transition of fossil fuels will take some time.
Okay.
I completely agree. It will take time, but we have to avoid opposing the values. I mean, today the world is not ready to work without any fossil fuel. So do not oppose them, but let's work on decarbonization and so on, and slowly fossil fuel will decrease, of course. And by the way, when we say fossil fuel, we think about gas. What is interesting about gas is that we are going to produce more and more renewable gases, or let's say green gases, which is also a way to decarbonize as well. So I think it will be a mix, and the mix will evaluate over the years. It will take time.
Yeah, definitely. And so talking about this and those fossil fuels and gas companies, as you mentioned. Like with the energy transition, people thought that those companies, those fossil fuel or like gas companies, were about to be like the losers, or were like be like excluded from the energy transition before. But it seems like with hydrogen, all companies can actually take part of it. So we could have like only like kind of winners. So how are those companies? How are companies transitioning and adapting into this low carbon hydrogen economy? How does that work? To just like transition. Frank, yeah, maybe.
I don't think they're going to be the losers. They could be the winners. In fact, we can see that they are transforming themselves. Remember that ENGIE, we used to operate coal power plant. We had exploration and production as well. We are transforming ourselves and building on our experience. In fact, these fossil fuel companies, they've got a huge experience in safety, operation in offshore, for example, building pipelines and so on. In the hydrogen economy, you will need companies able to build very large complex of production, pipelines, storage, and so on. So they have learned a lot with fossil fuels, but it's just adapting themselves. So we need these companies, and we can see that they are evolving now. You cannot start from scratch saying, oh yes, I want to be an actor of hydrogen. I don't believe it, because it has to be serious, it has to be structured, it has to be with a lot of safety. Safety is of prime importance. So I think we don't have to blame anybody, because a couple of decades ago, everybody was willing to have to work in a petrol company, oil company, because it was very important. So we have to be careful as well. But they could be the winners.
Yes. Pete, yes?
Yeah, I think Frank made some great points in terms of lessons from the fossil fuel industry and what they've been able to achieve in terms of infrastructure and moving products around the globe. And certainly, to apply that going forward is going to be very important. I think the other thing that potentially, and I've seen, from a startup perspective, is capital. So there's a lot of infrastructure and investment coming from major energy companies. So in California, I know that I think the largest or second largest number of hydrogen fueling stations have been developed by Shell, right? And so they're making bets, and there are other companies, other energy players around the globe who are making those same sorts of investments, which makes it it's not only government funding, it's not only to rely on tax revenue, but people see the long-term profitability. So I think as there's as we go through this transition and there's less and less incentive to deal with carbon intensive fuels, the money will naturally flow into other solutions. And I think those companies are particularly well positioned based on history, as Frank said. So I think, there don't necessarily have to be losers, right? There can be winners across the board, hopefully.
Which is great.
If I may add, Florian, 60 years ago, Engie was one of the companies inventing liquefied natural gas between Algeria and France. And it was the beginning of this, and producing country, importing country, having boats, shipping the LNG and so on. What happened 60 years ago with the companies like Engie, it can be the same now with hydrogen or any hydrogen-related or derived molecule like methanol and so on. But this is something new, but we have to build on what has been built 60 years ago, like, for example, for LNG, because in fact, there was a lot of similarity between, not so many, but a minimum of similarity between liquefied natural gas and hydrogen, because there will be some producing countries, importing countries, transit countries. I think it's interesting to build on what has been done in the past by all these companies.
Mm-hmm. Yeah, and talk about like production and the comparison with fossil energy. I'm actually going to take a question from the audience from Amza, which is like really interesting. He's asking, how much does it cost to produce like 1 kilowatt of energy from hydrogen, and is it cheaper than from that fossil energy? Is it cheaper? Pete, yeah.
Well, okay, so I think there's maybe a little bit to unpack that comment. So hydrogen is an energy carrier; it's not an energy producer, right? So to look at it a kilowatt hour basis might be a little bit the wrong lens to view it. I would say, what we talked about earlier in terms of enabling more solar, more wind. Those are among the lowest costs of according to the levelized cost of energy from solar, wind are among the lowest producing. So when you talk about electrification, the role hydrogen can play there as an energy storage medium, it enables low cost energy. As far as the production of hydrogen itself, green hydrogen, it sits at about $5 per kilo. And fossil or gray hydrogen is probably about $1. So there's quite a bit of work to do, I think, in order to bring that price down to make them comparable. And we can talk about that, perhaps a little bit later, but I'll turn it over to Frank and see if he has any thoughts on that.
Mm-hmm.
No, I agree with what Pete mentioned. Hydrogen is not meant to produce electricity. Basically, this is more to be used in the industry for heavy mobility and so on. And And the idea is the cost is important, of course, but you have to think also about the total cost of ownership, especially for mobility. Not only the price per kilo, this is the cost of the usage, the saving you've got compared to an electrical car or electrical bus. The time for recharging or for fueling is much less. The autonomy is much more. So you have to think globally. And also for industry, you have to think about the tons of carbon avoided and so on. And you have to add a lot of cost and consideration. It's not only the price per kilo. This is not really an answer, but each project is complex, and each project also depends on which area, which conditions, which renewable energy condition, transportation, and so on. So it's not so easy to make shortcuts, I would say.
Yeah. So do you think that those clean hydrogen production costs will become more competitive with other like low carbon alternatives in the future?
Yeah, so I think we're seeing a lot of, a couple factors, right? So one is just economies of scale as we see the demand for green hydrogen and their carbon incentives, and there's a huge role in government incentives, which again, perhaps we can talk about later. I won't, in the interest of time, I won't bring it up right this second, but yeah, just economies of scale, demand for green hydrogen is going to lower the cost significantly. And then innovation, I think, again, you have more companies like our company, Hydrogen Works, working on the next generation of electrolyzers and so forth. And then in the transportation and distribution side, a lot of money and investment looking at that. So when you look at optimizing, across the value chain, each, segment trying to become 10% more efficient, it adds up. And you get to a point, I think, within, a decade where the delivered cost of green hydrogen could be comparable to gray hydrogen without incentives. And then once you figure in the incentives, which need to be there in the beginning to transition, as Frank said, you don't want to have your entire model built on government subsidies forever. But as we transition, I think that's a really important point to realize. But yes, there's a pathway to getting to dollar per kilo hydrogen production, which is again similar to what you get from gray hydrogen, and that involves economies of scale, which we're beginning to see, further innovation, and then experience and learning from those increased projects.
Mm-hmm. Indeed, Peter, but we can also expect further decrease in the cost of renewable energy, because as you know or you don't know, but 60% or so of the price of the renewable hydrogen is made for the renewable electricity. So as long as you continue to decrease in terms of cost, the cost of your renewable hydrogen will decrease as well. So two factors that will make it more affordable in the coming years.
Mm-hmm. Interesting question as well from the audience, from Ankit. The question is, what do you think the trajectory would be for green hydrogen? Would it grow like solar PV or like nuclear, which grew like rapidly from 1970 to like 1990, then plateaued? Or do you think it's going to be different? I mean, I'm not asking for like, any kind of like projection from out of anywhere, but how do you see at least the trajectory of green hydrogen? Pete, yeah?
Sure. I think, if you look at the cost of solar is a good example, right? For the model hydrogen could follow. So in the early 2000s, 20 years ago, we were talking about how expensive it was, to build solar panels, and, how much the government subsidies were required to make solar work at all. Now we're in a place where, again, I said the levelized cost of production for electric, the two lowest costs. Well, there's hydro, but then in terms of scalable solar and wind, right? And so you've seen the investment, you've seen the effect of increased demand, lowering the cost. I think hydrogen could follow a very similar path.
Mm-hmm. Okay.
I agree, and I don't see any plateau coming. I mean, I mean, 3 years ago, we were expecting really a boom. There was the sanitary situation, as you know, which was there was also some slow decisions regarding subsidies. IRA in the US is very new. I think 2022 was really the beginning. 2023 will be really a lot of implementation, a lot of FID taken on project, I believe, because now IPCEI in Europe are ready. There will be an acceleration, and I can see. I expect this to be increasing. The beginning has been a little bit slow for the various reasons I've mentioned, but now people are ready. More and more actors, stakeholders are ready to invest money and invest time and in development of projects. So I expect 2023 will be a very interesting year.
Okay. Great. So I wanted to switch a little bit, and we talked about the kind of transportation, storage, and I wanted to come back on this because you mentioned it, Pete, and I think it's very interesting to know, because people talk a lot about storage of hydrogen and transportation. Will this renewable energy will be generated or produced where it's needed in the future? Or does it need to be still stored, transported? Is it hard to do? What's the best way to store hydrogen? Can you tell us a little bit about that?
Yeah, I'll give you, the number of questions there, so I'll give you some brief thoughts kind of on each of them, or as many as I can, I guess. So in terms of hydrogen, I think, so in the US, the Hydrogen Hubs initiative is, one of the goals of that is to produce hydrogen, at least regionally. And one of the ways to decrease, the need for logistics and the cost of logistics is to decrease the distance between the source of production and the end customer. So that's part of what hydrogen is. So basically, as we scale up in hydrogen, we see it in more places. The transportation costs are going to be should fall just from that factor. I think the other aspect is in terms of small scale production, modular production. There are advances being made there where you could have on-site hydrogen production for certain applications. It might be economical. And so building it directly at the end consumer, I think in the future is a possibility as well. And then I think in the transportation aspect, there's certain issues that we know, the pressurization and the energy density being the two factors, I think, which are add the most cost and are being worked on. I do like the idea of hydrogen being transferred or being transported in other chemical means. So methanol is an example. So e-methanol is basically it's methanol generated from a green hydrogen, and basically there 100 ports worldwide, 50 plus with bunkering capabilities that have been developed over the years. So why not exist if we can leverage existing infrastructure such as in the methanol case to deliver, or ammonia as another carrier. You have these globally developed infrastructure and supply chains that you can basically slot right into with other derivatives. So I think all three of those are pieces that will help in address some of the transportation distribution costs.
Mm-hmm. Yeah.
Maybe to complement. Today, there is no hydrogen infrastructure in terms of pipelines and so on. So you can see that there are some hydrogen projects being developed next to an industry which is needing this hydrogen. So hubs are being built with a primary first consumer, a first off-taker, I would say. But the idea will be to have multi-usage users around. And more, there will be some hubs built, and you will have to connect these hubs, either by boat or by pipelines or by... It is the beginning of an adventure that was the same for liquefied natural gas 60 years ago, but this is the beginning. So there will be a need for production, for transportation, pipelines, vessels, because today there is hardly no vessel. How is it going to be transported, liquid, gaseous, as an ammonia, as a methanol, and so on? this is being invented. This is what is exciting in this industry. And this is why we need to be connected with startups, because we need new blood, we need new ideas, we need to be clever, because it's really the very beginning. And we need to sometimes to take decisions. When you have to build a boat, a vessel which will transport the molecule, what kind of molecule, and to go from where to where. This is why this connection, like you organize today, for example, with startups, is a very good initiative, because large companies like us, we need also to be connected with this, because sometimes they are more agile and we need some new ideas. The electrolyzer of tomorrow, the vessel of tomorrow, the molecule of tomorrow. This is what is interesting, but this is the beginning.
Yeah, and it's very exciting. Great. And so another thing that I wanted to touch upon today is definitely one of the big industry, like I said at the beginning, the big trends. I would say today is around transportation. Of course, like there are others, but transportation and the car industry, I would say, is really interesting to look at, because we have different alternatives for energies for the cars, and we have hydrogen coming into the market. My question is our country ready for hydrogen cars? Do we have like fuel stations? How does it work? Pete, you wanna touch a word on that?
Yeah, I can talk a little bit about the market I'm most familiar with, which is California, where I'm based. So the California Energy Commission has done a great job in terms of incentivizing distribution infrastructure. So there are either 100 stations, hydrogen filling stations that have either been constructed, been approved for construction, or in construction, or have been approved for construction. And those are up and down the state. And the idea is to build, that confidence that if you do have a hydrogen car, that you can safely, the next town you're going to go into has a hydrogen filling station, and you're well aware of where those are. I think that's huge, because it's always the what we refer to as the chicken and egg problem, where if there's not confidence that you can find the fuel, there's not really incentive to for the consumer, to switch over and to something that's uncertain. And so I think building out the infrastructure is a huge piece. Again, as I've seen here, the government involvement has played a key role in doing that. And then again, other companies, Shell, Iwatani, major companies internationally that see the promise of the hydrogen future as well. So I think the infrastructure, is a huge piece to making sure that the advantages of hydrogen can be taken, can be realized. Otherwise, it's a lot to ask for a consumer if they don't know where they can fuel up regularly, and it's going to be difficult to find fuel. That dissuades people from moving. But once those kind of things are in place, I think it drives adoption much more quickly.
Mm-hmm. And so, Frank, talking about what Pete was describing, on an investment standpoint, do we need to like drastically invest in those like distribution technologies, like to speed up the general use of hydrogen cars, like, which means like invest in those like fuel stations, etc., or how do you see this?
Okay, before talking about mobility, I will say a word. I think you have to think hydrogen in terms of decarbonization. And of course, you need volume, because we need to produce hydrogen, as mentioned by Pete. We want to be at scale to reduce the cost and so on. So the main interest would be industry first, of course, because it is large volume. Okay, but of course, mobility is great, especially I would say heavy mobility, trains, boats, buses. For passenger cars, for the moment it's a little bit early, because there are not so many stations. Because passenger cars, they are still expensive. It could be good for a captive fleet, for example, when you've got a company having 100 cars that are in the same driving in the same area and so on. It can be interest. Then you have a volume. Then you don't need a lot of stations. Otherwise, you need to build corridors. And this is what we've done in France with the Région Auvergne-Rhône-Alpes. There was something clever I want to share with you. 3-4 years ago, we decided with the region around Lyon to apply for subsidies. And in order to cut the chicken and egg problem mentioned by Pete, we said we'll seek for subsidies, but part of it will be for the capex on the hydrogen refueling station. So we got 20% of the capex, but there will be subsidies for the first 1,000 vehicles. So we were reassured at the beginning that we could invest on the station, but there will be at least the first 1,000 vehicles, which will help to quick start the idea. And I think this is very clever to think about the production and the usage at the same time, because what happened in Germany is that they have built a lot of stations, but there were not so many cars. So we have to be inventive and clever. So we have to invest in the stations, yes, to answer your question. Ideally, co-invest together with the territories, a city and agglomeration and so on, because then they will also help to, like Paris, for example, not to choose Paris, but if the city or the agglomeration is part of the project, then it will help developing some let's say, ideas, incentive, publicity, advocacy for that.
Yeah, very interesting. Pete, just to answer and see how it's working here in the US, do you think we need more kind of like partnerships or like gathering together, or like is it already the case? Not on the federal level, I'm saying like just like state with other states or like other regions of the world to work together. Do you think like it's enough or not?
I'll say that again the recent DOE hydrogen hubs program is kind of designed to bring public-private partnership, which I think is key in all this. It can't just be the government pushing things out there. You have to have access to capital markets in order to deploy these technologies, and you have to see returns. So I think the idea, again, of hydrogen hubs has been a huge step forward in terms of creating across the U.S. a number of areas where you'll see hydrogen development, and correspondingly see the infrastructure and investment come in, and also then return to the communities. Excellent, green jobs, high paying, and a stable tax base. So I think there's great incentive for everyone to kind of cooperate. And then, as Frank said, I think the missing piece, which probably does need a little more work, is then figuring out how to connect the hydrogen hubs and what's the best mechanism to do that. And I think that's probably maybe stage 2 of the journey, is to understand if you build out this infrastructure, how do we piece it all together so we do have global interconnectedness. I think that's something that still needs work and will be developed in the coming years.
Mm-hmm. Frank, yeah.
Maybe to add on these hubs, I mean, we have to think. I mean, we are at the beginning. So when you build an hydrogen production plant, for example, you have to think on the next step, and the next step one day could be exporting. So ideally, if you find a place where you've got an industry, when you've got a port not very far, even if we don't know yet how it will be exported and where, the idea is to think about the next step. Of course, the hub could be in the middle of the USA, for example, not next to the sea, because there would be such hubs, of course. But if there are some hubs next to the sea, this is very interesting. And this is also interesting. You mentioned the word the word partnership. I think developing a hydrogen project is really more a co-construction, especially when a producer like Engie, we have to work with our client or off-taker, because sometimes we are developing the hydrogen production at their premises, in their field. So we have to co-develop together to meet their expectations, to meet their requirements, anticipate the future. And ideally, we can also co-construct with the public authorities, because I think it's a win-win-win situation to have some, because you are going to create employment. You are going to. There are a lot of interest of working together, or sometimes also with the subcontractors, especially key electrolyzer manufacturers, for example. Or it's interesting to work together, and sometimes you can work with your competitors. We were developing a project jointly with Total Energy in France today because we think that we are complementary. This is great. And the project we inaugurated in South Africa in May last year, which is together with Anglo American. This is our first 3.5 megawatt electrolyzer. We have co-designed it together with Anglo American, who is our off-taker. This is co-designed. The government is having a look at what we are doing. They are thinking about creating an hydrogen valley. This is very clever and very exciting to work with all these stakeholders around the project.
Thank you so much. Pete, maybe last word, because time is running. I had a million other questions, but unfortunately we have to move on. Pete, if you want to say something to wrap this up.
Since we didn't get to it in the flow of the questions, I'll just again emphasize the need, I think, for subsidies, particularly in the beginning. I mean, I think at least most of us in the industry that I've spoken to think direct price on carbon is probably the largest incentive. So I came out of the renewable diesel industry. When I first started, there was one plant basically in the world producing renewable diesel. And then you had California came with low carbon fuel incentive in 2009. And, sitting here 15 years later, it's likely that within the next couple of years, every drop of diesel in the state of California could be renewable diesel, right? And that's a direct result of having a price on transportation carbon. Similar carbon incentives across industries would have, I think, a similar effect for using green hydrogen, bringing the cost down immediately, and then also spurring further investment, further scale up, and bringing down the cost of production, so you don't need those subsidies in the long term.
Mm-hmm. Yeah, thank you so much. Thank you again for accepting my invitation. I hope we can join another panel one day, because it's so many things to say, obviously, and see the evolution is really interesting over the years. So thank you, Pete. Thank you, Frank, for joining today, and stay with us for the second part of the event today.
Thanks for your kind invitation.
Thank you.
Thank
you.
you.
Appreciate the invitation.
Bye-bye.
Thanks. Bye-bye.
Cheers, bud.
Great. So we're going to continue the event with the startup presentation. And so today we were supposed to have 6 startups, but I believe Floris is really sick today, so he's not going to be here. So we're going to have only 5 pitches. Great. So without further ado, we can start with the first startup for today, which is Ali Power, and Walt. So Walt is going to join me in a second, and so here is his presentation. Hi. Hello, Walt.
Hello.
How are you doing?
Hey, can you hear me?
Yes, I can hear you and see you perfectly.
Excellent.
So thank you for being with us. We pulled up your presentation. You can move it yourself or tell me next. And yeah, so the floor is yours, Walt.
Thank you. Hello, everyone. My name is Walt Alfred. I'm CEO of Ally Power, and I'll be presenting the future of fuel, hydrogen and electric refueling stations, and hydrogen retrofits. Next slide. So we think that our solutions provide 4 different ways to decrease greenhouse gas emissions. The first is with green hydrogen. We plan to generate 1,200 kilograms a day, which is enough for 30 trucks or 240 cars. We'll also be producing green electricity on site, green sodium aluminate, and then green transportation. Next slide. So this is a look at our patented hydrogen and electric refueling station, and this is how the back end of the station works. We feed in aluminum and sodium hydroxide into the boiler, and that generates both heat, hydrogen, and sodium aluminate. The electricity that we generate is given 2 different choices to either charge electric battery vehicles or go to the grid. And then the hydrogen that we generate is also given 2 choices to either be dispensed to vehicles or be run through the stationary fuel cell. Next slide. So as the previous speakers were talking about in terms of the hydrogen hubs, our solution kind of fits within that by being a distributed hydrogen station. So we can place our stations along interstate highways to enable the hubs to be connected. Our stations will be a small footprint, around 2 acres, and provide on-site generation of electricity and hydrogen through the chemical reaction of aluminum, water, and sodium hydroxide. Next slide. This is a look at what our station can provide. On the top right is what the customer will be driving into. Below that is an example of some of the electric battery charging stations that can be provided there. The most of the electricity will be provided by the steam turbine, which will be on site, and it will be distributed again to the grid or to the electric battery charger. And then the hydrogen produced on site will be given the choice between dispensing to vehicles or going through the stationary fuel cell. Next slide, please. This is a look at one of the vehicles that we are looking at in terms of retrofitting. We plan to take out the existing engine as well as the catalytic converter, put in a hydrogen fuel cell as well as a hydrogen storage system, and that will make the vehicle into a hydrogen fuel cell zero emission vehicle. We do have 3 price points for this conversion. The first will just make the vehicle zero emission, the second will extend the range, and then the third will provide extended range and vehicle to grid capability. Next slide, please. So some of our technology benefits and values for the stations as well as the retrofits. We will be both electric battery vehicle as well as hydrogen capable. We plan to be safe, economical, distributable, and zero carbon. That's one of our major points, is that we will be zero carbon. Next slide. This is a look at our management team. I'm the founder and CEO. Our chairman, Salman Saul, has a long career that began in the Israeli army, developing the first unmanned aerial vehicle. Our CFO, Tova Jaffe, her previous position was as the treasurer of the Smithsonian. Our business development expert in the MENA region is Khalifa Tamer. Next slide, please. Irvin Owens is one of the board of directors. Irvin is actually the founder of the Cabell Foundation, which helps with financial literacy. Thomas Mierswa is another director of the company. He is an associate professor at the University of Maryland. Leon Shahabian is another director, and he is a principal at the Global Insights Group. He provides a great authority on press releases as well as strategy for the MENA region. And then Fred Ketcher is another director. He has 50 years of experience on Wall Street and provides a lot of financial acumen to the team. Next slide. So these are a look at our current partnerships as well as initiatives. So we do have several MOUs with the University of Texas. We have also conducted some conversations with the U.S. Export-Import Bank. We do plan to generate a lot of our equipment in the United States or in Europe, and then export it to where we actually are going to be building our stations. We already do have some partnerships with some French companies in Sakhalin Green Energy as well as Carbon Optimum. And then United Industries International and AI Consolidated are some of the companies that we work with to expand our market potential. Next slide.
I believe that was the last slide.
Yes. So thank you very much for your kind attention.
Yeah, of course. Thank you so much, Walt, for your presentation. Great technology, definitely in line with our discussion. Thank you again. Great. We're going to move on with Mahmoud from Kaloji. So Mahmoud, you can start. The floor is yours, and you can tell me when to go next on the slides.
Great. Thank you very much. Can you hear me well?
Yes, I can hear you perfectly. Thank you so much.
Perfect. So hello, everyone. My name is Mahmoud Shirazi. I'm co-founder and CEO of Kaloji Solutions, a company with an innovative thermal management technology for electric and hydrogen transport in the future. Next slide, please. Yeah, so in Kaloji, we are basically experts and innovators in thermal management. We have started in 2020. We have a team of more than 20 employees, a very strong IP portfolio, and we continue to generate more patents. Our expertise has been known both internationally and nationally by Startups Insights in 2022, who mentioned us as one of the top automotive startups worldwide in battery thermal management. And also, we were known by the government of Canada in an innovation competition. Next, please. So the problem we're trying to solve is basically temperature control due to heat generation in different components of the future transportation vehicles. So if you look at a modern vehicle, basically they will use either battery, fuel cell, both, and also they have power electronics, high power electronics. And all of these components, they generate a lot of heat and they need to operate in a very specific temperature range. That's exactly what we do. We have developed a new technology that can address this problem. This problem is important because it has direct impact on safety, performance, price, and range anxiety in the future vehicles. Next, please. This is our solution. It is called Unity for uniform temperature. As you can see, it looks like thin metallic plates. However, it has a thermal conductivity 10 times more than copper. It can also reduce aging in basically electric and hydrogen systems by 30%. It can increase the range in winter conditions for electric vehicles in 35. And also it is passive, no connections, very reliable and low cost solution. For the batteries, it is compatible with prismatic, pouch, and cylindrical, and we're now exploring the use of this in a fuel for the thermal management of fuel cells. Next slide, please. The way it works is based on the heat pipe legacy. So basically liquid vapor phase change. That's why it can offer this very high thermal conductivity. It is thin and, as I said, very lightweight. Next slide. So for the fuel cell, it's an application that we are exploring now. Thermal management in fuel cell is an issue because the fuel cells generate a lot of heat and they need to operate in a specific temperature range. Our solution, it has some interesting features. First of all, it is thin, it is lightweight, and it can be put between the bipolar plates. It can provide a uniform temperature, which is extremely important in the lifetime of the fuel cells and batteries, both. And it has a very high heat capacity. It can transport a lot of heat without any problem. In terms of integration, it works great with air cooling systems. I mean, better or equivalent to liquid cooling systems, which is really an innovation. It is low cost, very reliable, as I said. And also we can imagine creating microchannels for air and water transport to be used directly as bipolar plate in a fuel cell. Next, please. So these are part of our customers and collaborators. As you can see, in lithium-ion batteries, we work with companies in aerospace, Bell Uniter. We also work with a large OEM, automotive OEM. For hydrogen, we're working with Safran in France, also Bell Uniter again. And with power electronics, we're working with a large German technology company and a tier 1 automotive technology. Next, please. So our business model is based on making and selling the components. We are basically a manufacturing company. We're not a consulting company. However, the first part in our basically projects start by a thermal study. We look at the customer's current system, we analyze it, and then we propose a new kind of integration using our components. I should mention that we can offer, and we have done actually the whole system, the key thermal management solutions, and not only one component. However, next stage on that is that we prototype with the customers. We make some prototypes to test the results, and finally we sell them the parts. Our early adopters have been really mostly aerospace and marine, so niche markets. But our goal is really for automotive markets for the high volume expansion of the company. Next, please. So now why work with us? First of all, you will have access to an innovative and game-changing thermal management technology. It could be applied to a range of different thermal challenges in the future transportation. As I said, batteries, fuel cells, and power electronics exist in all these vehicles in different levels. We have also a proven track record success with previous partners. We are used to work with large organizations, and typically they're very satisfied. They start with one project and then they bring other teams to work on different projects with us. And finally, we have this dynamic, innovative, and dedicated team that really ensures reliable, timely, and professional results for your company. Next, please. So thank you very much. It was the end of the presentation. If you have any questions, please feel free to contact me, mahmoud.shirazi@calogisolutions.com. Thank you very much.
Thank you so much, Mahmoud. That was a really great presentation. Thank you so much. Great. So we're going to move on with our next presentation. So elemental recycling with Ron. Hello, Ron. How you doing?
Good, Flo. Thank you for letting us talk today.
Yeah, of course, of course. Great. So your presentation is here, and the floor is yours.
Thank you. So elemental recycling, we're transforming waste using cutting edge technology. Next slide, please. As we know, this is a massive problem. 380 million tons of plastic are made in a year, and less than 9% is recycled. Next slide, please. So with our technology, we can transform tires, plastics, the plastics that are currently end up in the landfill, the bioplastics, contaminated plastics, the plastics that are used on your consumer electronics. We can grind it all up and run it through our process. Next slide. So, there's a lot of discussion this morning on what hydrogen can be used for. We're in Texas, so there's a lot of hydrogen pipeline that runs from Louisiana all the way down the coast of Texas. So you have industrial transportation and hopefully growing into a home market. Next slide, please. So what we do is we have a single step patented process. We upcycle those plastics and tires, really any organic, and we produce a high purity green hydrogen and a graphene nanomaterial. Next slide. So fairly simple process. We, as I said, single step. We can take any of the commercial plastics 1 through 7, virgin, contaminated, film, bioplastics. We run it through, and we break that down into the elemental bonds: carbon, hydrogen. You'll see some sulfur. There's sulfur in the plastic. But we recover all of that. So we have, while we produce that high purity graphene and hydrogen, we have no emissions, no tars, no hazardous gas or waste. As a matter of fact, to date, everything that's come off the process has had a commercial value for us. Next slide. So this is our version 1. This was the test machine, full-size test machine that we made. Through that, we ran polypropylene, polyethylene, PET, styrene, PVC, tires, a lot of material that was destined for the landfill. So floor sweep, other contaminations, it might have been titanium dioxide or labels or metals, but we ran through this process. Next slide, please. We're currently in the process of finalizing version 2. We're going to be doing acceptance testing of that machine the end of this month, and it will be delivered to our facility here in Houston. But the company that built the machine is international, so we can build these in Europe. We're actually talking to a company in Australia right now about partnering with them. Depending on the material that you put in, if you're putting in polyethylene, polypropylene, it's designed to run about 25,000 pounds in this current size of machine, and you'll produce about 5,000 pounds of green CO2 neutral hydrogen, the remainder being graphene. So the machine itself is about the size of a large SUV. Next slide, please. So kind of a summary slide here. Single step continuous. We run 24/7. No waste streams. We can process a lot of feedstocks, including the halogenated for polyvinyl chloride, brominated plastics, those kind of things. Our hydrogen is 99.9% pure, and our graphene, we're making a spherical turbostratic single multi-layer graphene carbon nanoonions with a 99% purity. Next slide, please. So this is results. The gas sample was done by Southern Petroleum Labs here, and then images of the SEM and the TEM of the carbon that we've produced, the graphene. Next slide, please. So management team is comprised of Tom Samuels. He helped us get our initial funding, and myself and Ian Bishop, we're the founders. I'm the chief technology officer. Environmental mechanical engineering background, whereas Ian's done multi-business startups. Next slide, please. We are working with several different universities, University of Houston, Texas A&M. Rafaela is a PhD. She has experience in graphene and other carbon nanomaterials. Raj is a professor at Texas A&M in Arlington. And Robbie is retired, spent 40 years doing research and development at Alcoa. Next slide, please. So we have a strong patent portfolio, both domestic and international. Next slide, please. And then how can we work with different companies? Well, our machine is portable. We can help with the end of life scope 3 wastes. Again, we produce a CO2 neutral hydrogen for operations or manufacturing purposes. We're talking about other groups about using the hydrogen from waste for local or microgrids. And then we produce that CO2 neutral graphene that's useful in resins, concrete, electronics, and also as a conductive material in EV batteries and supercapacitors. The other thing is the machine is portable, so it's easy for us to build a machine local to a facility to minimize that waste transport away from the facility. And the last slide is just our contact information. And I'd like to, again, thank you for the opportunity. And appreciate it.
Thank you so much, Ron, for your presentation. Thank you. Great. So we are going to move on with our next presentation, which is HiStar. So we're just going to wait on Sine, and she's going to present.
Hello,
Hi.
everyone.
Hi, can you hear me well?
Yes, can you hear me?
Yes, perfectly. Thank you so much for being here today.
Oh, my pleasure. So,
Great. Yeah, go ahead.
So hello and greetings from Norway. My name is Synne, and I'm going to present about HiStar. Are you able? Sorry, but I'm not able to see the presentation. Are you able to see the presentation?
Yes, I'm able to see the presentation.
Okay.
I'm actually passing the slides right now.
Okay, but then I just will go ahead. So at HiStar, we specialize in ultra-efficient PEM electrolyzers for the production of green hydrogen from water electrolysis. Next slide, please. We have a patented solution which provides superior efficiency, and we have an available high-volume manufacturing process. In 2025, we will have full-scale stack production capacity, and this will be over 1 gigawatt over 1 gigawatt. So at HiStar, we are based on over 15 years of research on PEM electrolyzers. We were founded in September of 2020 by 3 co-founders. Fredrik Moville, he is the former CEO of Upper Turbines, Magnus Thomassen and Alejandro Barnett, who are the 2 people that developed the patent at SINTEF. SINTEF is then the largest research institution, the private research institution here in Norway. Since 2020, we have raised 384 million Norwegian kroner, which is about 35 million euros. And our key investors are AP Ventures, SINTEF Venture, Firda, Mitsubishi Corporation, Finindus, which is the investment fund of ArcelorMittal, being the world's 2nd largest steel producer in the world, Nippon Steel Trading, Trustbridge Partners, and Hill House Investments. So we are based in Høvik. This is right outside of Oslo. Here we have our headquarters and offices, our R&D, test, and pre-production facilities. We're currently building our first unit that's going to Equinor. And then at location number 3 here, we have the gigawatt fully automated production facility where we are currently ramping up our production. So I've said that we have a higher efficiency, but here I will try to explain a little bit more how are we managing this. So on the left-hand side of the figure, then we have the on the left-hand side of the figure, you can see the conventional PEM electrolyzer. And then in the middle part, there you see the membrane. So all electrolyzer manufacturers are trying to reduce the thickness of the membrane because the thicker the membrane, the larger are the losses in the system due to heat. And so but how Hystar has solved this problem, or the problem here is that when you have hydrogen, hydrogen can cross over the membrane over to the oxygen side. And if the membrane is too thin, this will happen. And then you get an explosive mixture on the anode side. So how we have solved this problem, we have changed over the water inlet from the anode side over to the cathode side. And this opens up the possibility to ventilate with air on the anode side. So if any hydrogen is crossing over our thin membrane, then we can just dilute it with air. And this gives several advantages. We both get a higher efficiency. We get a higher control of our stack, so it has an increased safety feature. And also it enables us to use components from the fuel cell industry, which are already standardized and mass produced. Next slide, please. So we have 2 different ways of operating our system. We can either run it at conventional production rates. There we will use about 10 to 15% less energy than others on the market. Or we can run it at the same amount of energy as other PEM electrolyzers, and then we will use about 2 to 3 times more, or produce 2 to 3 times more hydrogen from that energy. So if you have a renewable system or with the PV or wind park, then when you have an excess energy, you can produce a lot more hydrogen in those time points, and then you get a lot better business case. So at Hystar, we produce stacks that goes into our containerized solutions, and we produce modules that go into large plants. At the moment, we have about 100 megawatt of production capacity for the coming year and about 200 megawatt for next year. And in 2025, we will have over 1 gigawatt of production capacity. Next slide, please. So at Hystar, we have a patented solution providing a superior efficiency. Our electrolyzers are the safest on the market. We have an automated high-volume mass manufacturing process to serve the multi-gigawatt electrolyzer equipment market that we've been talking about today. Our solutions are modular and scalable, and we are a well-funded company with market-leading competence on electrolyzers. Thank you so much for taking the time to listen. My final slide is, I would just also like to add that if you want to discuss more about how we can look into electrolyzer systems, then please get in contact.
Thank you so much, Sine. That was great. Thank you. All right. Great. So we are going to continue with our last presentation today. Hello, John. How are you doing?
I'm doing well.
Great. So for Protonian Energy, John, the floor is yours, and you can tell me when. Yes, we can hear you perfectly. And you can tell me when to pass the slide.
Okay. On behalf of Protonian Energy, I would like to thank Choose Paris Region for this invitation to tell you about Protium and our hydrogen production technology. My name is John Rosenfeld, and I'm Vice President, Commercial Strategic at Protium Energy. Next slide, please. Protium Energy is a US-based company that has developed and operates technology that reforms ethanol or natural gas liquids into low-carbon hydrogen and hydrogen-rich products. Our steam non-methane reforming technology, or SNMR, can produce hydrogen at a lower cost with less energy than conventional SMR. And when producing hydrogen from ethanol with CCS, our carbon intensity can be negative. Next slide, please. This is a depiction of our modular SNMR system, which can be scaled from 15 metric tons per day of hydrogen production to over 150 tons. It can reform any non-methane hydrocarbon or oxygenated hydrocarbon, like ethanol, into hydrogen and other product gases. Modules are shop-built and scalable, integrating proprietary technology with standard process modules. Next slide. Our business model is to partner with ethanol producers or oil and gas midstreams to provide them access to the hydrogen market. The EU is a major ethanol production market, and this map shows that France is leading the way as the EU's largest producer. Our base plant uses about 53 million liters of ethanol feedstock per year and can be scaled up over time. Next slide, please. Our target markets are transportation, gas to power, direct pipeline injection, and low carbon ammonia. On the transportation side, we're working with fuel cell truck manufacturers and refueling companies to implement their fueling strategies in California and throughout the US. Sustainable aviation fuel is another application for our low carbon hydrogen. On the gas to power side, we're working with a power company to mix hydrogen produced from ethanol into its turbine fuel. And ammonia is a natural product extension for us. Next slide, please. Our SNMR reforms feed gas and steam into a reformant. CO2 and hydrogen are then separated using industry standard process modules. Our products include fuel cell grade hydrogen, hydrogen-rich designer fuels, synthetic natural gas, ammonia, and CO2. When residue gas is used as a feedstock, our base system produces 14,700 kilograms per day of hydrogen. With ethanol feedstock, the base system produces 19,000 kilograms per day of hydrogen and 320 metric tons per day of biogenic CO2 available for sequestration or utilization in products such as e-methanol. Next slide. Our technology has been developed over 7 years with an investment of over $65 million. The core technology was used in commercial operation in 2018 to reform flare gas into SNG. The system was then upsized and optimized for hydrogen production and is ready for feed engineering and installation. We have a demonstration facility in Bryan, Texas. Next slide. Protium Energy has 35 patents and patents pending, including an application with the European Patent Office. Next slide, please. This chart highlights how Protium's SNMR stacks up against other technologies. SNMR has low carbon intensity, low CapEx per kilogram of production, is modular and scalable, and has lower water and power usage. Next slide, please. Here's a recap of some of Protium's competitive advantages. Flexible feedstock, multiple products, flexible design, low cost, low carbon, and low water usage. Next slide, please. Our business model is flexible. We can produce hydrogen on a build, own, operate basis or on a tolling basis. We can partner with a producer or offtake partner and produce hydrogen at their location. Next slide, please. 2023 will be a busy year for us. We're working on projects in California, the Appalachian region of the US, Nebraska, Kansas, North Dakota, and the UK. Next slide, please. This final slide provides an overview of Protium Energy. We're a lean organization with significant R&D investment and a technology ready to deploy. Thank you for this opportunity to tell you about Protium Energy and what we do.
Thank you so much, John, for your presentation. Thank you. Great. So this is the end of the presentations. Thank you so much to all the presenters. Before we end this meeting, I just wanted to show you the agenda for our next event. So our next event will be online on April 6th around supply chain and logistics. So thank you again to all the presenters. If you have any questions, you can reach out to me either via email or LinkedIn. And if you have a project to expand in the Paris region, you can reach out to Cécile Jupin, which is the business developer manager for US internationally. And if you have, if you would like to join the Global Open Innovation Network or program dedicated to large corporations, you can reach out to Hélène Tanti, which is the head of development. Thank you again for coming by, and have a great rest of your day. Until next time. Bye-bye.